Dear students, in this session we are going to discuss how to find the solutions of a partial differential equations of very simple type. That is the first topic we are going to discuss. Then we are going to see 4 different standard types of PDEs. That is called as type 1 PDE, type 2 PDE, type 3 PDE and type 4 PDE. There are 4 different types of PDE we are going to study and discuss how to find the solution of those types. That is the next topic. So in this session we are going to see first consider only a simple partial differential equation and how to find the solution. By just inspecting the partial differential equation, we find the solution by just doing the integration. The other 4 standard types we are going to discuss next, and each of the standard types has a different method to find the solutions. So now we will start with simple partial differential equations, and just by using some integration we are going to find the solution. So that is the first topic we are going to see. So this comes under unit 2. According to our syllabus, this topic comes under unit 2. Actually, the topic first we are going to discuss is the solutions of partial differential equations in some simple cases. Some simple partial differential equations we are going to consider first. So now first I will write the problem. Suppose the question is solve dou square z by dou x dou y equals to 0, and always z is a function of 2 independent variables, and these are x and y are independent variables, and we need to find the solution of this simple partial differential equation dou square z by dou x dou y. Solution in the sense we need to find this z, which is a function of x and y. So we are just going to do some integration. So the above partial differential equation can be written as actually this is the given partial differential equation. That is, I simply write like this. This can be written as dou by dou x of dou z by dou y. It can be written like this. Now what we are going to do is we are going to integrate. Integrating with respect to x. See, we are going to do the integration with respect to x. Dou by dou x of dou z by dou y. The integrand, and then x is the integrating operator, and since we are integrating with respect to x, we treat y as a constant, and so in here we write 0 is on the right hand side. If integration of 0 is 0, and we had one constant because this is an indefinite integral, so the constant is written as some function of y, because we are integrating with respect to x, treating y as a constant. So that constant I am going to write it as some function of, which implies just if we integrate this, we get dou z by dou y, which is nothing but f of y. So now to get z, again we have to integrate with respect to y. Now integrating with respect to y, we get see this term we are integrating with respect to y. So here right hand side this becomes f of y and we are integrating with respect to y, and since we are integrating partially with respect to y, x is treated as a constant. So the constant of integration we write it as some function of x. In this step, this function of y is a constant because we are integrating partially with respect to x. So that is, if we integrate this quantity with respect to y, we get z, which is equals to integral of f of y dy plus some function of x. This is the required solution. That's all. This f is some function and pi is also a function. Okay. So this is a simple PDE and its solution. This is how we get the solution. This is very simple PDE, so we just do the integration and get the solution. And now next problem. There are many problems given in this section. Solve dou square z by dou y square equals to sin y. So this is a problem. Given dou square z by dou y square equals to sin y, same like the previous problem, you can just, this can be written as, that is dou by dou y of dou z by dou y equals to sin y. Now integrating with respect to y, partially means we just keep the other variable as a constant. Integrating with respect to y, we get integrating with respect to y. The same thing we have to do in the right hand side also, sin y dy, and since we have to add one constant of integration, that can be some function of x. That is, this becomes integration of d of dou z by dou y, which is equals to integration of sin y is minus cos y plus some function of x. That is, this is nothing but dou z by dou y equals to minus cos y plus pi of x. Now I want to find the solution, that is z. So what is the step we are going to do here is again integrating with respect to y. Integrating with respect to y partially, we get, so if you integrate this with respect to y, we get z. So again this one we are going to integrate with respect to y, and this one also we are going to integrate with respect to y. This is a function of x, we are going to integrate with respect to y, but we are integrating partially with respect to y. So we have to add another constant which is a function of x. Already I used pi, so I use the other symbol psi. You can use any symbol. It is, so the solution is integration of minus cos y is minus sin y plus pi of x is a constant, but we are integrating with respect to y. So after integrating we will get pi of x times y plus some function of x. This is the required solution of the given partial differential equation. This is the required solution. It's a required solution. Now we go to the next problem. This third one. Solve x plus y into dou z by dou x equals to 0. These are all simple PDEs. That is, by doing integration we can get the solution. Not always this is possible. So next section we are going to discuss the standard types of PDEs, which are non-linear also. So it's not thus we can find the solution by integration. So whichever method is applicable, we can use it to get the solution. So now to find the solution of this PDE, so this can be written as the given x plus y into dou z by dou x equals to 0. That is, this can be written as dou z by dou x equals to minus of x by y. I can write like this. Now what we have to do, we are going to integrate partially, integration partially with respect to x. The meaning is we keep y as a constant. That is the meaning is. So if you integrate this term with respect to x partially, we get z. The right hand side also we are going to integrate partially with respect to x. Since we are integrating partially with respect to x, we have to add one constant. That constant must be a function of y. I name it as pi of y. It is z equals to minus 1. Y is a constant, and integration of x is x square by 2 plus a of 1. This is the required solution of the given PDE. This is the required solution. Now we go to the next problem, problem number 4. Solve dou square z by dou x dou y, which is equals to x square plus y square. So the given PDE is dou square z by dou x dou y equals to x square plus y square. That is, we can write this one as dou by dou x of dou z by dou y equals to x square plus y square. So now first we will integrate x with respect to x partially. Integrating with respect to x partially, we get, so if you integrate this with respect to x partially, I get dou z by dou y, and the right hand side also we have to integrate with respect to x partially. Since we are integrating with respect to x partially, the constant of integration must be some function of y. Some function of y. That is dou z by dou y equals to, we are going to integrate with respect to x partially, so this becomes x cube by 3 and y square is a constant, and I will get like this, plus some function of y. And now this partial differential equation, this one we are going to integrate with respect to y partially, so that I get z, the solution. Integrating with respect to y, integrating with respect to y partially, we get z equals to integration of this with respect to y and integration of this also with respect to y, and this also must be integrated with respect to y, and since we are integrating with respect to y, we have to add some function of x as a constant, because function of x will be a constant. That is z equals to, this becomes x cube y by 3 plus y cube x by 3 plus pi of y integration with respect to y plus psi of x. There's one more step I can write. This is nothing but, we can take xy outside, 3 also we can take outside. The remaining is x square plus y square plus integration of this pi of y plus psi of x, and this is the required solution. Required solution. And now this completes the fourth problem. Now we go to the next problem, number 5. Solve x into dou z by dou x equals to 2x plus y plus 3z. This is the PDE, and we need to find the solution of this PDE. Solution. So first we will write the given differential equation, partial differential equation, x into dou z by dou x equals to 2x plus y plus 3z. So what is this? This is same as, what is dou z by dou x? So dou z by dou x is nothing but divide by x throughout. So 2 plus y by x plus 3z by x. So we get like this. And this is a linear partial differential equation. Okay. And now we know that. So now little bit some substitution methods like this we are going to do some little bit different than the previous problems. So now you see, what is dou by dou x of z by x cube. Partial differentiation of z by x cube with respect to x. So, but z is not a constant, it depends on x as well as y. So while differentiating with respect to x, you have to be very careful. So that's UV method we can use. First I keep 1 by x cube as a constant and differentiate z with respect to x partially. Then I keep z and differentiate 1 by x cube with respect to x. So what is the thing? I get minus 3 by x power 4. Differentiation. So differentiation we get like this. This is nothing but 1 by x cube, we take it out, and the remaining thing is dou z by dou x minus 3z by x. This is what we get. This is nothing but dou by dou x of z by x cube. Multiplying, therefore what we are going to do is multiplying both the sides of, see, I will give the name for these equations. I give this given differential equation as 1, and this one is also, I name it as 2. So now what we are going to do is multiplying both the sides of the second equation by the integrating factor, say 1 by x cube. We are multiplying this factor on both the sides of 2 so that we can do the integration. So what we get is 1 by x cube of we get 1 by x cube of dou z by dou x minus 3z by x. Something that 2 by x cube plus y by x power . Yes, now the second equation I will write it here. Little bit change I am making. Dou z by dou x is equals to 2 plus y by x plus 3z by x. I name this as 2, and now sorry, I am not going to give a name for this equation. Let it be without name. And now this one, I bring this 3z by x on the left hand side. That's all. That is the only change we make. Other things as it is. 2 plus y by x. This equation I name it as 2. Now, so we know that we just take one step here, we find the value of this quantity here. Okay, so what is dou by dou x of z by x cube? This quantity. Now what we do is multiplying both the sides of the second equation by 1 by x cube. So what happens, you can see both the sides of 2 is multiplied by 1 by x cube. So this becomes 2 by x cube and this becomes y by x power 4. That's what we have done so far. And what is this value? Just now we derived expression for this. That is nothing but, it is for that purpose only we are multiplying by 1 by x cube. This quantity is nothing but dou by dou x of z by x cube, which is equals to, as it is, the right hand side we keep as it is, 1 by x cube plus y by x power 4. Now it is easily we can integrate the both the left and the right hand side. That is why we call that 1 by x cube as an integrating factor. Now integrating with respect to x partially we get, so if we integrate with respect to x, I get z by x cube on the left hand side. The right hand side we are going to integrate with respect to x partially. And this is also we are going to integrate with respect to x partially. Since we are integrating with respect to x partially, y must be a constant. So the constant of integration we are writing it as some function of y. That is z by x cube equals to, this is 2 is there, so integrating x power n plus 1 by n plus 1. Plus here we get y into square of minus 3 by minus 3 plus some function of, that is, so z equals to, just cross multiply this x cube on both sides, so get minus x minus y by 3 plus x cube into 5. This is the required solution. So okay, so this is the integrating factor. If you multiply on both the sides of 2, we can easily integrate it. So for that purpose only we call it as an integrating factor, that we need to find it. This is the problem number 5. Now problem number 6. Solve dou square z by dou x square equals to a square z. Given that when x equals to 0, dou z by dou x, dou z by dou x equals to a sin y, and dou z by dou y equals to 0. Some conditions are given on the solution. So dou z by dou y equal to this when x equal to 0, and dou z by dou y is also equals to 0 when x equal to 0. This is a condition on the solution of the PDE. Now, if z is a function of x alone, actually z is always a function of two variables. This is a general one, but it may happen that it may be a function of x alone. It may not depend on y. If suppose that is the case, we are discussing that case. If suppose z is a function of x alone, then it becomes, this differential equation becomes an ordinary differential equation, because it depends upon only one variable x. So there is no need of using the partial derivative symbol. So that is why if z is a function of x alone, that is z is a function of x alone like this, then this PDE given can be written like a ordinary differential equation, and we use the method we studied in ordinary differential equation to find the solution of this case when z is a function of x alone. Then the given PDE can be written as, then dou square z by dou x square minus a square z can be 0 is same as ordinary differential equation d square z by dx square minus a square z equals to 0, because this depends upon only one variable, if that is the case. Okay, which implies, so for this kind of ordinary differential equation, this is of the type, see like this, this is of the type d square minus a square into z equals to 0. So what is the auxiliary equation? M square minus a square equal to 0, which implies m equals to plus or minus e. So what is the complementary function is same as the solution. So z equals to some a into e power of ax plus b into e power of minus ax. This is the solution of this PDE. Sorry, this ODE. So for this ordinary differential equation, the solution is z of x, because we consider the case when z is a function of x alone. Z of x equals to a into e power of ax plus b into e power of minus ax. But our z is always a function of two variables. Hence, the solution of 1, this is 1. Solution of the given partial differential equation is, we are going to replace this a and b by some function of y. Yes, z equals to f of y. Instead of a, we put f of y as some function of y into e power of ax plus pi of y into e power of minus ax. I name this equation as 2. Now, this is the solution of the given PDE. So, the problem is not over yet, because they are given some conditions on some two conditions are given. This is the first condition and this is the second condition when x equals to 0. So using these two conditions, we are going to find this f of y and pi of y. Then the resulting equation after substituting them is the solution of the equation 1. So for that we are going to do some more steps. We are going to do. So what I have to do is differentiating these two partially with respect to x. So what happens? So what is dou z by dou x? Just concentrate on equation 2. Dou z by dou x equals to, this is a function of y. As it is, we can write. So differentiation of e power of ax is a into e power of ax plus, what is differentiation of e power of minus ax? We get minus a into same pi of y is a constant, e power of minus ax. And similarly, what is dou z by dou y? Dou z by dou y equals to, and now this is a constant, this is a variable. So f of y differentiation with respect to y is f dash of y into e power of ax plus pi of y differentiation is pi dash of y into e power of minus ax, because we are differentiating with respect to x partially. Now we are going to use the condition given in the problem. When x equal to 0, what is given? Dou z by dou x equals to a sin y. You can see the condition. See, when x equal to 0, highlight this. This is condition, we are going to use it now. Okay, this condition we are going to use. So go to dou z by dou x. Okay, that is equal to what? A into sin y. Not always, only when x equal to 0. Right hand side, wherever x is there, you put 0. So what happens? We are going to go to this equation and substitute in place of this a into sin y. Therefore, a into sin y equals to, right hand side, we have to put x equal to 0 everywhere. Wherever x is there, you put 0. A into f of y minus a into pi of y. This is what we get it. So cancelling that a throughout on both sides of the equation, we get f of y minus pi of y equals to sin y. I name this equation as 3. And what is the other condition? This is the next condition. This one. This is also true for when x equals to 0. Okay. So we are going to use dou z by dou y equal to 0 when x equal to 0. So go to this equation and put this equal to 0 when x equal to 0. So what I get? Our While substituting the second condition, we get f dash of y minus plus, sorry, it should be plus, f dash of y when x is equal to 0, f dash of y plus pi dash of y equals to 0. And name this as fourth equation. See, our aim is to find f of y and pi of y and substitute in this equation 2 and the problem is done. For that only we are doing these steps. Now I cannot use 3 and 4 to get f of y and pi of y. So what I do is we take equation 3 and differentiate with respect to y throughout. Differentiating 3 with respect to y, we get f dash of y minus pi dash of y equals to sin y differentiation as cos y. I name this as fifth equation. Now use 4 and 5 to find f dash of y and pi dash of y. So from 4 and 5, we get, suppose we add 4 and 5, I get, so we get f dash of y, 2 times f dash of y equals to cos y by 2. Okay, so we get like this, and using this in equation 4, we get pi dash of y equals to minus 1 by 2 cos y. That's all. So it seems this is f dash of y. So what is f of y? Integration. Integrate with respect to y throughout. So we get 1 by 2 sin y plus some constant, we make it, because this is fully a function of y alone. So I just put some constant. Don't put some variable x or some function of x. That's not right. So this is same as, if we integrate it, I get pi of y, which is equals to minus 1 by 2 sin y plus some constant, constant of integration, I name it as b. So now you go to equation 3. What is equation 3 tells? F of y minus pi of y. That is f of y, what we found, f of y minus pi of y equals to what? Equals to sin y. So half sin y, 1 sin y, and this get cancelled. Just everything cancel, which implies a equals to b. So a and b are equal. That is what is, we get it from equation 3. So now, therefore, now you go to the equation 2. From 2, the solution of the given PDE 1 is z, which is equals to f of y. What is f of y? 1 by 2 sin y into e power of ax plus pi of y minus 1 by 2 sin y into e power of minus ax plus, see, actually this is equation number 2. F of y is, this a is also included, so just we will get, finally we will get this term also, because a into e power of ax plus b into e power of minus ax, because f of y includes of sin y plus a. So which is common in these two terms, of sin y into e power of ax minus e power of minus ax plus so we get of sin y into e power of ax plus e minus e power of minus ax plus since a and b are equal we can substitute in place of b a. So we get a into e power of ax plus e power of minus ax. So finally we get it's nothing but 1 by 2 sin y, and this is nothing but 2 sine hyperbolic sine of ax, sin h ax plus a into 2 cos h ax. So finally this can be written as sin y into sin h ax plus 2 times a into cos h ax. This is the solution of the given partial differential equation. Here this z is a function of both x